Good day everybody, we've been given a beautiful question. We are expected to find the area of the shaded region. So we got a circle and we got a triangle inscribed inside the circle. So this is the approximate image of the circle. Now you got a center. I'm trying to locate the center. Okay, that's the center of the circle. Now this is given to be as 20, 20 and 24 units. We are expected to find the area of this region. Okay, so I'm going to take this as A, B, C. Okay, so this is the figure, and let's get started. So this is an isosceles triangle. Now because this is an isosceles triangle, if I were to draw a line from the top vertex, a perpendicular line to the base, then that line would divide the triangle into equal parts. In other words, the line would divide the base into equal parts. So this is going to be 12, this is going to be 12, and the line dropped is a perpendicular. So that would mean this angle made is 90 degree, this angle made is 90 degree. Okay, so let me take this to be O and this point to be some D. We have to find the radius of the circle. Foremost, we need to get the radius of the circle. Okay, so before we could get the radius of the circle, what we need to do is we need to get CD. We need to find CD. Now let us consider triangle CDA. Now since the triangle is a right angle triangle by Pythagoras, we have, so what do we have by Pythagoras? CD squared plus AD squared is equal to AC squared. So CD squared we have to find. AD squared is 12 squared, AC squared is 20 squared, 20 squared is 400, 12 squared is 144. So CD squared is 400 minus 144, which is 256. CD squared is 256, CD is root of 256. So CD is equal to 16. So this is got. Now let OC be equal to R, which is the radius of the circle. So since CD is equal to 16, so this would mean my OD would be equal to 16 minus R, right? This entire thing is 16. I'm taking this to be as R. This entire length is 16 units. So from 16 units, I have to take away R units. If I were to take away R units, this would be 16 minus R. So OD is equal to 16 minus R. Okay. Okay, so we have got that OD. So now what I'm going to do is I need to get this region, right? So to get this region, we will have to find the radius. So let me get the radius. So this is the next step. Step number 2. We need R. Okay. So how are we going to get R? Now what I wish to do is, from the center, I would like to connect the point B. Okay. Now what is this? This is also a radius. Right. Now OB is equal to OC is equal to R. So we have a line from the center to B, which is also a radius. So that means I can take this entire length to be equal to R. Now what I wish to do is I would consider triangle ODB. Now this is a right angle triangle. Right angled triangle. Okay, so this would mean I can apply Pythagoras. By Pythagoras we get, so what do we get by Pythagoras? OD squared plus DB squared is equal to OB squared. OB squared is R, DB squared is 12 squared, and OD squared is 16 minus R raised to the power of 2. I expand this, I get 16 squared negative 32R plus R squared plus 12 squared is equal to R squared. R squared gets cancelled, and then I get 16 squared. Now what I can do is I can add 16 squared, which is 256, 12 squared, which is 144. This will give me 400. On this end is 400. Push this 32R to the other side, it will become positive 32R. Therefore R is equal to 400 divided by 32. Okay, so this is the value of R. Okay, fine. Let this be fixed in that corner. Now if you want, we can reduce this, because 8 will divide here 5 times 8, and there is a 0 there. 8 divides here 4 times, so I can this is a reduced amount, 50 divided by R. In fact, I can just reduce this 2 more times and 25 times, so R is equal to 25 divided by 2. This looks a much better value. Okay, now go back to the figure. Now this is R, this is R, so we have an isosceles triangle. So what I wish to do is, since it's an isosceles triangle, I am going to draw the height for the triangle. So height means from this end, from the main vertex, from the center's vertex, the central vertex, you drop a perpendicular. So if you were to drop a perpendicular, what happens if you were to drop a perpendicular? That would hit the base. It will divide the base into equal parts. 2 equal parts it will divide. So this part will be 10 and this part will be 10, and this is going to be 90 degree. Now what I have to do is I would have to find the value of theta. Okay, theta, this is central angle. In other words, the sector angle is important. Now this is a sector. If you were to see it carefully, COB is a sector. So I want to get the sectoral, the angle of the sector. So for that I need to get the angle, one of these angles. If I were to get this angle theta, then I could always get the sector's angle. So draw the right triangle. Just to draw the right triangle that you see here. So I'm going to draw this right triangle. This is what we have got. So this point is 90 degree, this point is 10, and this length, we don't know that length is going to be h, and r we know. This from the center to C, that's going to be r, right? We know that. So r is equal to 25 over 2. Now this is theta. I want to get theta. So what I'm going to do is, from here I would have to get Let me take sine theta. If I were to take sine theta is, this is opposite side 10 divided by hypotenuse 25 divided by 2. So this is going to be 20 divided by 25. So this is sine theta. So 5 divides by 4 times, 5 divides by 5 times. So this is 4 over 5. So my theta, if I were to get this theta, my theta is going to be sine inverse of 4 over 5. So we need a calculator to extract the value of theta. So let us do that. Okay. So sine inverse, let me just check the sine inverse value. Sine inverse of 1 is equal to 90. Okay, that's perfect. That's fine. So now I can have sine inverse of 4 over 5. So let me get the value of 4 divided by 5. That's going to be 0.8. Okay, fine. So sine inverse of 0.8. This is giving me 53.13. So I'm taking an approximate value. Let me just take it as 53. So theta is equal to 53. Approximate value of 53. Okay. So 2 times theta. So this is 1 theta here. So 2 times theta. So 2 times theta is going to be 106. So this is the value that we are getting. Now this is going to be my angle for the sector. Okay, so now that we have got the angle, the sector angle to be as 106, it's time for us to find the value of h. I'll be using the same triangle. Now from here h can be calculated, the height of the triangle. So h squared positive 10 squared, 25 divided by 2, that's 12.5 squared. So h squared is going to be 12.5 squared negative 10 squared. Let me calculate 12.5 squared. That's 156.25 minus 100. So I take away 100. I would be getting 56.25. This is my h squared. So h is equal to square root of 56.25. This has to be calculated. So square root of 56.25. That is going to give me h to be as 7.5. Now we are expected to find the area of the triangle. Now why do I have to find the area of the triangle? Because the required area, which is this, is equal to area of sector. From the area of the sector, you subtract area of triangle COB. Okay, so that is the reason I'm going to find the area of the triangle. So let me get the area of triangle COB, which is nothing but half into base into height. Now the area of triangle COB is equal to half into, we already have 20 for the base and the height is 7.5. So 2 divides here, 10 times 10 multiplied by 7.5 will give us 75. So this is the area. Okay, area of triangle COB, units. Now we have to find the area of the sector. Area of sector is equal to, now if you remember, I've got 106 to be the angle. Place the angle, divide by 160, multiply by pi, and this in turn has to be multiplied with the radius squared. Now radius we have found out to be as 25 over 2, and you multiply it twice. This is what we have got. Now what we can do, we can directly multiply everything off. 25 into 25 is 625. This is 106 and this is pi, and you got a 4 there. 2 times 2 is 4. 6 4s are 24, 2 4 3s are 12, 13, 14, and you got a 0 there. So what I'm going to do, I'm going to multiply 625 multiplied with 106 multiplied with 3.14. Okay, so this is equal to 208025 divided by 1400 divided by 1440, and that is giving me 144.46. This is the sector area. So therefore required area is equal to 144.46 minus 75. So from here you take away 75. So this would give me an approximate area of 69.46. So what is this? This is the required area of the yellow region that we are talking about. Thank you everybody.